All right, this video is day 2 of your post-test, so make sure you're watching the right video. And we start off right away with number 1. So number 1, assume that f is a linear function. If f of 8 equals 10 and f of 4 equals 9, create an equation. So basically, these clues right here, these are ordered pairs. So if it makes you happy, write them as ordered pairs. And then if you need to find the equation of a linear function, there's a couple of ways you could do this, but this is way back in our first couple days of school. The first thing you're going to need to do is calculate the slope. So remember, slope is y2 minus y1 over x2 minus x1. You do need to know that. You're PreCalc. So let's see, 9 minus 10 over 4 minus 8. And when you reduce that fraction, you get a 1 over 4. So that is slope, and then you're going to choose your favorite point. This is how most of you do this question. Some of you do a little different approach, but I like this point. So I'm going to use x equals 8 and y equals 10, and I'm going to plug that into the point slope formula. Again, this is a formula you have to know. So y minus the y coordinate, which is 10, equals the slope you just found, which was this 1/4 right here. And then x minus the x coordinate, which is 8. And then it doesn't actually say how to write your function. So, I mean, technically you could just kind of add 10 over here and be done with it. But I'm going to go one step further and I'm going to distribute the 1/4. So this is 1/4 x minus 2. And then if you add the 10 over here, you end up with y equals 1/4 x plus 8. So as far as formulas you need to know this formula. And you should know this formula or some other derivation of that formula. Now, technically, these are the same formulas. Don't forget about that. All right, part 2. Number 2 is also part 2. So you need to find the exact answers of this quadratic, no decimals. So using your graphing calculator to estimate is not going to be an accurate way to do this. So you could either use quadratic formula. You could use completing the square. Just remember, if you're using quadratic formula, you have to remember what the formula is that is not given to you. Negative b plus or minus square root of b squared minus 4ac all over 2a. Or you can do Mrs. Bruzzo's favorite method, which is completing the square. I love completing the square. So the first coefficient's a 1, and then the middle term here, the b value, is even. So this is a great candidate for completing the square. You're going to leave a space for a constant. You're going to add the 11 over to the other side, and then you're going to balance your equation out by leaving a space over there as well. So remember, in order to find the blank, and it's the same number both times to balance, you take the middle term, which is your b value, you cut it in half, and then you square it. So middle term cut in half is negative 3. Negative 3 squared is 9. So why did you do that? Because now this quadratic factors beautifully into x minus 3 quantity squared. And then over on the right side, 11 plus 9 is a 20. And now you have a square rootable problem. So if you square root both sides from this point, this is where your two solutions arise. So you have x minus 3 is both positive and negative. Now don't say square root of 20 and don't give me a decimal. You're going to need to break that down, PreCalc. This is square root of 4 times square root of 5. So that would be 2 square roots of 5. And then your final solution step would be to add the 3 over. So 3 both plus and minus 2 square roots of 5. Those are where you're getting both solutions. And I would just leave it like that. You don't have to separate them. I mean, if you want to get fancy, and you want to say 3 plus 2 square roots of 5 and 3 minus 2 square roots of 5, that's fine. So up to you on the method there. This question is again on part 2. Saving all the good ones for part 2, I guess. We're throwing a ball from the top of a building with an initial velocity of 80 feet per second. And then apparently the top of the building is 22 feet. It's not a very impressive building. But we're going to need to get this typed into y1 in our calculator. So pause the video, get everything typed in. So I'm currently in the standard window, and that window will not be appropriate. And that's actually the first question. They want you to sketch it, and they want you to determine an appropriate window. So instead of zoom fit and playing with the window that way, just use your brain a little bit, guys. X, or t in this case, represents time that the ball is in the air. So negative 10 seconds is a weird place to start. Let's start at 0. And frankly, I don't even know if we have to go out to 10 seconds. That's probably too much, but you know what, for now, let's just leave it. You can try zoom fitting now, but it's usually not going to work very well. When it's the ball questions and, you know, eventually they're going to hit the ground, I like the ground, I like to see below ground a little bit. So I always start at negative 10. But remember, you threw the ball off of a building that was 22 feet in the air, and I'm assuming you, well, it had velocity, so it went up in the air even beyond that a little bit. So, I don't know, let's try 30. Not really sure. I'm really bad at throwing balls. All right, here we go. Ugh, bad job, Abruzzo. We got to go back and adjust that window. That y value, well, actually, I'm going to pull back the x to 7, because 10 was way too far. And the y was nowhere near high enough. So, I don't know, let's go like, I don't want to mess with this too much. I'm taking a test and I'm in a hurry, so I'm just going to go like 200 and see if that works. I mean, it's not the greatest window. You could definitely pull back the y a little bit, but that works for me. I think when I originally keyed this, I went to 150. So, if you have the time to kind of play around with the window, that's cool. Otherwise, you just need an appropriate window, which I know has a lot of gray area. What's appropriate for your window and my window, we might have a difference of opinion. So when they want you to fill out the window that you used. For x's, I went from 0 to 7. So I'm going to be checking to make sure you don't do something weird with the time. And then for y's, you can start at 0 technically. I like to go -10, and then I went up to 150 when I changed it. And then of course you're going to sketch it. There's the, oh boy, that's ugly. That's the ground. Oh man, that's terrible. That is not at all what it looked like. So make sure yours looks a little better. It does say, when does the ball hit the ground? So back to my calculator. The place where it hits the ground is right here where it crosses through the x-axis. So when I pull up the trace or the calc menu and I want to command it to find a 0, which is where your function hits 0, the first thing it says is give me a time before it hit the ground, and we're already there, so I'm going to hit enter. And then give me a time after it hit the ground. So like 1, 2, 3, 4, 5, 6 would be after it hit the ground. Remember, I always hop because of my delay. And then guess, you don't really have to guess, just hit enter. Alright, and it does say round to the nearest tenth, so 5.3 is the answer I'm looking for there. And label it please with seconds. This guy right here. And we found that by going to the calc menu and then finding the 0. And then it says, during what time intervals was the ball more than 100 feet above the ground? So, to answer this question, what I would do is I'd go back to y equals, and I'd type a 100 into y2. Because that'll at least give you a visual barrier. So it hit 100 feet right here, went up a little more, and then hit 100 feet again. So you need to find both of those times, which would be commanding it to do an intersect. So 5. Now this time, when you hit enter, 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 it's going to default to the closest one. So I need to kind of jot down 3.7 on my paper somewhere. And then we're going to have to do that again. But when you hit enter the last time, and I've never done this, I've never tried to hop. I wonder if my guess will work if I just type a 2. I don't know, let's find out. Yeah, it did. So you need to get closer to this one was my point. So 1.3 is the other time. So remember, and I'm going to add that to my picture, my glorious picture. Here's roughly 100 feet. So right here is 1.3 seconds, I believe, and right here was 3.7 seconds. So the time where it was more than 100 feet was from 1.3 to 3.7, in interval notation, of course. And then explain how to find the average rate of change from 3 seconds to 5 seconds. All right, so I'm going to trust that you guys can write some words and sentences for me, but basically you need to go, I would just go to your table, and I'd figure out the height when it's 3 seconds and 5 seconds. So, ignoring the red function, just looking at the blue one. At 3 seconds it's 118, and at 5 seconds it's 22. So for me, I like when I write those down as ordered pairs, because essentially rate of change is slope. And I'm very comfortable finding slope, because I just did that on number 1, right? So rate of change, which we really know is slope, would be like 22 minus 118 over 5 minus 3. Now you do get a negative value here. You get negative 48. But that makes sense because from 3 seconds to 5 seconds the ball was falling. Kind of. So you're going to label it, of course, guys, negative 48, or dropping. You can say 48 feet per second. Make sure you get that label in there. You are pre-calc, and I expect that from you. All right, moving along. We already did number 4 because it was on part 1. So now we're on number 5. So we have our friend the square root function, and it says what's the parent function? That's this guy over here. They already told you that. Just make sure you know you're using the right parent function. And then apply these transformations in order. So a vertical stretch of a factor of 2. Vertical stretches happen outside of your function. So the 2, this guy right here, the vertical stretch of a factor of 2, will be outside of the square root. And then there's a horizontal shift of right 3 units. So a horizontal shift happens inside with the x, and it kind of has a built-in negative, so it's opposite, right? So right 3 units would look like that. And then at the very end, there's a vertical shift of down 2. So that's a vertical shift outside. The important part there, guys, is that you don't use parentheses in this case. Because that vertical stretch happened first, it gets applied first to your math. So please be careful of your transformation order. All right, this also is on part 2. I want you to compute a composition question of f of g of 7. If you don't like that notation, you can change it for this notation. But the point is, you got to start on the inside. So find g of 7 first, which would be 3 times 7 plus 1 over 2. Now, you guys know to use parentheses if you're typing that in your calculator in one step. And this is a 22 over 2, better known as 11. And then, if this is really an 11, now it says find f of 11. Okay, so function f right there. And if you plug in an 11, I always use parentheses because I get nervous. 121 plus 1 is 122. Why do I feel like I messed something up? No, that's good. That final answer you get, that is the composition evaluation answer. All right. I don't know why I changed color there. Let me go back, make my slides pretty for my friends who are looking at my slides. All right, we're on the second page already. Part 2, this question says, find the inverse. Oh, I love finding the inverse on these. So the first step is to switch the x and y. And then you have to do a lot of algebra, and you got to solve for y. Now, this time, don't worry about notation. I already named it y inverse for you because the original function was called y. So switching the x and y, it becomes x equals 5y plus 1 over y minus 3. And then we're going to kind of treat this like a proportion to free up the math. If you cross multiply x times y minus 3, you get xy minus 3x. Last time we tested this, I mean, you guys really did very well on this question. But some of the mistakes I saw were people not distributing this part fully. So 1 times 5y plus 1 is 5y plus 1. And then you have too many y's in the problem right now, and you got to solve for y, so your first task is to bring all the y's together. I don't really care how you do this. Most of you subtracted the 5y because you like to bring y to the left, which means you're going to add the non-y's to the other side. So when you kind of step back and look at what you have here, you have xy minus 5y, which can't combine. These are gone. And it equals 1 plus 3x, or 3x plus 1. Now, I look at this expression right here. There's a common y you can factor out. And when you factor out that common y, you still have, what do we have? X minus 5 equals 3x plus 1. And then final step, you're just going to, you're trying to solve for y, so you're going to divide by x minus 5. So that gets written up here. These canceled, obviously. 3x plus 1 over the quantity, x minus 5. Love it. Love that question. All right, already done on part 1. Already done on part 1. Already done on part 1. Okay, there we go. Oh, everyone's favorite question, finding k. So first you have to identify where the zeros are for your function, and then also indicate multiplicity right below that. So 1, 2, 3, 4. This right here, this is negative 5 with a bounce. So there is multiplicity 2 at x equals negative 5 because of the bounce. This is a really important clue, so keep that in mind. All right, there's another x-intercept at 0 and then another one at 2. So when it says work for finding k, they do give you another ordered pair somewhere up here. It says right here, when x equals negative 2, y equals negative 288. Ordered pairs work as well. If you won't like that notation better. here's what I would like you to get in the habit of doing. Somewhere in your paper, I want you to write down like the skeleton of everything plugged in except for x, y, and k. So y equals some mysterious k value, and then remember that first x-intercept, which will be a factor of x plus 5, has multiplicity 2. So right away I got that. And then you can just say x or x minus 0, I don't care. And then x minus 2 would be the factor for x equals 2. Now we're going to go back and plug in these clues. So negative 288, I don't know k yet, I'm trying to find that. And this, sometimes kids leave off that squared, and that's why we, oops, didn't want to do that. This is why sometimes you get in trouble when you kind of rush through your work, and I know this is a very stressful test, so you're probably going to want to rush just out of necessity. But think about questions that you have made mistakes on in the past, and try super duper hard not to make them anymore. So a lot of kids left off the squared last time we tested this. Alright, my suggestion to you is to just get this typed in a calculator rather than securing your mental math, because you know what, you're freaked out right now, so you're probably not going to execute mental math as best as you could. And you have negative 288 equals k times, that number is, I'm sure I did this because I do it the same way. What did I get? 72. And then when you divide both sides by 72, you just found k. Now notice our k value is negative. And when I go back and look at this graph, this is definitely a reflected function, so I'm feeling really good about that number. And then you need to go back to this step, this skeleton, and just put negative 4 in place of k. Everything else stays. So negative 4, and then you can reverse the order of the factors, so like a lot of you would just put the x first, and then you'd say x plus 5 squared, and then x minus 2, but of course your teacher does not care. As long as your answers are equivalent and simplified properly, I really don't care what answers you give me, as long as they're right. Alright, that's on part 1, that's on part 1, part 1, part 1. My gosh, there's like no fun. Oh, this is part 2. Oh wait, is it? No. That one shows up twice for some reason. Okay, there we go, number 18, part 2. So solve this logarithmic equation. Recently did this test, and the idea is in order to get rid of a logarithm, you have to exponentiate, but not yet. Your first step is actually to isolate the logarithm by dividing by 5. So you have log base 2 of x equals 8, and you could either use the rewrite formula, or you could inherently understand that when you get rid of a logarithm, what you do is you're shoving the base underneath the problem, and you're raising the problem up to the exponent. That's called exponentiate. Exponentiate. That's the action. It's called exponentiation. So 2 to the log base 2 of x, these are going to knock each other out, and the x drops down. And then here you have 2 to the 8th power, which is something that I always have to type on my calculator because I don't remember that. Apparently it's 256. You should always check your answers on logarithms. I mean, frankly, you should always check your answer on everything, if possible, but that one was fine. This is another log equation. However, you have to use the properties of logarithms to rewrite it. So there's a big clue, right? You're going to need to condense these together. Log minus log becomes a division problem. So log base 5 of x over 6 equals 2. And now we're going to exponentiate again, this time with a base of 5. So the problem gets shoved up into the exponent position. 5 to the log base 5's cancel. And then 5 squared, of course, is 25, and then multiply both sides by 6, and you get 150. Awesome. All right. Properties of logs again. We just saw almost this exact question in your test. So I'm trying to solve for x. It's trapped inside of a natural log right now, so I'm going to free it up by exponentiating with his base, which is an e. So exponentiating with an e on both sides. This side is still e to the y power. Make sure you have that in the power. And then equals e to the natural log will cancel, and the x minus d drops down. And of course, you're just solving for x. So your final step would be to add the d over here. So the solution with x isolated would be x equals e to the y power, and then plus d. You guys actually did a beautiful job in my class on that question, and I bet in Mrs. Hoffbauer's class as well. So I got no fears on that question. I got big fears on this question, though. This question was a little tricky. The one on our review for the test, when we tested this, you had to kind of mess with the rounding to make sure that it got to the value that you needed. And sometimes on the tests, you didn't have to mess with the rounding. And then some of you did mess with the rounding even though you didn't have to, and that kind of caused you trouble. So the first issue, and this will be on your formula sheet, you get to use the formula n equals n sub naught r to the, I think it's t over h power. But you have to know what all those represent. So the final amount of amoeba that we would like is 17,500. And then the initial amount of amoeba is 47. And then the rate, it's a doubling time question. So the rate here is a 2. And then it doubles, this is kind of confusing because it says it doubles every hour. Like usually this says something like every 4 hours, every 3 hours. So this time h is just a 1. So if you kind of forgot about it, you're in luck. But just be aware that it's really t divided by h here. So this is like t divided by 1. Alright, so first step in solving this question is you're going to have to divide by 47. Sorry for the little space here. And you get a little tiny decimal, like 372 point something. So then you're going to have to apply the natural log, or common log, it doesn't matter, to whatever this does. I would leave it as a fraction, frankly, but apply the natural log to that number. And you're also, because these are gone, you're also applying the natural log to 2 to the t power. So here's what's going on. When you type the natural log of 17,500 over 47, or whatever decimal that is, you're going to get, oh, for Pete's sake, I didn't type that in. Here's what's going to go on. Your t is going to drop down in front. So you have natural log of, I'm just going to write the fraction because I didn't write down anything, equals t times the natural log of 2. So if you're trying to solve for t, your step is you're going to divide by the natural log of 2. And depending on how you truncated things, hopefully you didn't do too much truncation, this calculator, when you round to the 10th, comes out to t equals 8.5. So what you have to do now is you have to actually check that 8.5 is okay for the problem. So if you were to take t equals 8.5 and plug it into t up here, you get a number, actually I'm just going to do it down here. So if you do 47 times 2 to the 8.5 power, you get, I wrote this down, I swear, 17,016 when you round to the nearest whole amoeba. So we don't have to mess with the rounding any further. So this did get you over 17,000, which was the request of the question. So 8.5, what was the label on this? Hours is the time. Don't mess with the rounding there. And then be careful, I want to know how many amoeba over 17,000. Aw, snap. No! Abruzzo, back up. Back up. 17,500, girl. Read. Ah, for Pete's sake. Scrap all that. We didn't get to 17,500 yet. Alright, I gotta redo this question. So 8.5 doesn't work. So we need to round to 8.6. My bad. Alright. Well, I'm guessing 8.6. I don't really know. I'm gonna go type it on my calculator now. For Pete's sake. Alright. What were we at? 47 times 2 to the 8.6 power. Let's see if that works. What did I do? Oh, yeah, there we go. Alright, so when you round up to 8.6, I need to live my life over again on an answer key. You get 18, 2, 3, 7, and it rounds up to 7 for amoeba. My bad. So now it wants to know how many over 17,500 it is. Oh, that's embarrassing. Alright, 18, 2, 3, 7 minus 17,500. Get your bifocals out, girlfriend. Alright, 737 amoeba. Ugh, sorry. That's not how you spell amoeba either. Maybe I should stop recording. Amoeba. There we go. So you're up 737. I apologize. My bad. All right. Man, oh man, that was my bad. Keep going, guys. Thank goodness we're almost done. I don't think I can do much more. All right, we're going to need to pause the video because you need to get all this data entered. So our data is entered, and now that we have our data entered, we need to find it says exponential regression. So we go to Stat menu this time, go over to Calc, and make sure you're pulling up the right command. We're looking for exponential regression, which is 0. I entered my data into list 1 and list 2, so I need to change that. And then I always like storing the function just in case I need it later. Knowing me, I probably will. Alright, and then we're going to calculate, and it does say it's pretty specific on this test, to round to the nearest thousandth. So you're going to need to write down 4.912 times 2.836 to the x power. And you know what, frankly, it's not a great regression correlation coefficient, but whatever. They didn't care to ask me that question, so we're just going to write it down. That does make me a little nervous that I typed something wrong, though. Oh man, this is not my day. I did not type something right. Oh, for Pete's sake, stat edit. Yeah. Alright, right there, 49.3. Okay. So good thing we checked. Let's try that again. Stat. Calc. And then it was 0. List 1, list 2. I gotta store it again because I screwed up. That's better. Alright, so 0.99, yeah, there we go. 24.976 times, this is just going to round to 2.2 to the x power. Alright, write that down. Thank goodness we're almost done. And then predict the amount of mold in 2020. So remember it says right here years since 2010. So we're going to be plugging in a 10 for x. It doesn't really say, oh it does say we're to round to the nearest thousand. So use your regression equation in your y equals screen and either use your trace or your table. And you should get 25777.987. So I'm looking for a horribly specific, what's the label on here? It doesn't tell me. Oh, it's amount of mold, whatever that means. You need to be real specific that you're using the regression equation and not using your truncated regression equation. So use the one on the calculator, I guess, is the moral of the story there. Oh, goodness gracious. I think this is our last question. Thank goodness. And it's a doozy. All right, so it's about cookies and cupcakes, which doesn't seem very alarming. However, you have to be very careful how you are setting up your variables, first of all, and then after that, how you're setting up your equations. So we're trying to figure out the number of cupcakes and cookies that she sold. So let X stand for, it's up to you, but I'm going to say it's the number of cupcakes sold. And then Y could be the number of cookies sold. Now if you reverse those, it's fine, but your work is going to look different than mine. So the first question, or first equation, talks about money. So let's put all this money together. $3 per cupcake, and then $2 per cookie gives you a total of $44. This is the question I'm worried about. She's sold 3 times as many cupcakes as cookies. So a lot of kids think this means like 3 times cupcakes equals cookies. Well, that's not quite right, because in order for them to equal, you have to actually triple the other variable. So what we have to write down is cupcakes. In order to come up with the same number of cupcakes as cookies, you'd have to triple the cookies. So this is that weird backwards equation, so be careful. Now you're going to solve it. This is a great candidate for substitution. I'm going to substitute right there for x, 3y. So 3 times, not x anymore, but 3y plus 2y equals 44. Why did I switch colors? I don't know. And you have 9y plus 2y equals 44. So when you divide by 11, you get y equals 4. And then go back here, plug in y equals 4 and get x equals 12, but I need a sentence answer. So, and this is a good moment to check your math. If she sold 3 times as many cupcakes as cookies, and this is cupcakes, right? So you got to make sure that your math worked out to have 3 times as many cupcakes as cookies, which it did. So she sold 12 cupcakes and 4 cookies with an exclamation point. Okay, so that's the end of our day 2 post test. Make sure you're concentrating on the proper questions on the proper days.